Hello, good morning, everyone.
Namaste ji.
Namaste, namaste. Okay, so mostly you have joined, so we'll be starting with the presentation soon. Okay, is it visible? The slides are visible?
Yes, Ji.
Okay, so previously we covered how to create a data frame from a list, from a dictionary, and from a numpy array. Okay, we did the practicals of that also. Then we had creating data frame from CSV files. Okay, that we studied in presentation only. There was no practical accompanied with that. Okay, then we studied how to retrieve and modify the index and column labels. Okay, names of the rows and names of the columns. That is what is referred to as index and column labels. Then we had accessing data using lock and ilog. Okay, lock and ilog, the difference is very simple. Lock works with label names, names of the columns and names of the rows, index names. Okay, ilog works with position of the columns and position of the rows. Okay, zero row, first row, second row, like that. Okay, so we'll be first having an example of how to create a data frame from the CSV file in a practical session. And then in the last session, we covered how to create rows and to delete rows. Okay, that also practical implementation we'll cover after that. Okay, so starting with the creation of data frame from the files, we had this example already that we can put data into a CSV file, which is called exporting into a CSV, and we can import from a CSV also. So what we will do is let's take this data. Okay, let me copy this and let's move to a Jupyter notebook. Okay, this is the Jupyter notebook. So in the folder, I have a Jupyter file. Here, let's create a new file. On your computers, you can directly create a text file as you do in normal ways. Okay, creating a text file. It is as simple as that. So I have pasted this data into this text file. Then I have saved this text file. Okay, I'll rename this to a .csv extension. Let's call it data.csv. Okay, so now what happens is that in your folder, this is the file. Okay, text file that I've created. I have saved this text file in here. Okay, data.csv, and this DataFrames.ip ynb is our Jupyter notebook. So this is like your program file, code file, Python file. Okay, and this is your CSV file. Both are in the same folder. If you have to directly write the name, then they have to be in the same folder. Okay, so now let's come back to the Jupyter notebook. So first of all, what we have to do is we have to import pandas as pd. Okay. Now all you have to do is you already have the file, the CSV file, in which there are comma separated values. Okay. Let's take another look at that file. In the data.csv file, what we have is we have comma separated values, where the first row represents the column names. Okay. The name of the column for this first thing is not there because it is our row index. Okay, then we have name, then city, then age, then Python score, but there is a comma there, which means that this is the column for this name or this column. Okay, so moving on ahead, to create a data frame out of this file, we write df is equal to pd dot name of the function is read underscore csv. Okay, now this csv file can be very well created in Excel also. All of you know how to use Microsoft Excel. You can create this table, name, city, age, Python score, etc. in a Excel file, then save the Excel file as a CSV file. Okay, just click on save as, then select the file type as CSV, comma separated values. That will also create the same file. Okay, so you can create this file either way. So in this, we have to pass this file data.csv as an argument. So now df is created. If you try to print the value of df, you will notice that it is not what you'll expect. Okay, so we have this unnamed 0. Okay, because this is also treated as data 101, 102, 103, 104. Okay, and row indexes are specified as 0, 1, 2, 3. Okay, but we already have the row indexes. So what we will do is we will use the index underscore call value. Okay, index underscore call. Now this is a parameter named parameter. We will set the value of this. Let me admit someone is trying to join. Okay, so index underscore call. We can specify that we already have an index column, and we can specify its index, that the first one, index call is equal to 0, means the first column in our CSV file is actually the row index column. Okay, so now let's have a look at the same data frame. Now it is created as we wanted it to be. Okay, so index and score call is equal to 0 means that the first column is the row index in our CSV file. Okay, second name, then city, then age, then Python score. Okay, any doubt in this, how to create a data frame from a CSV file? Any doubt in this example?
No, Ji.
Okay, it is very simple. CSV file can be created in like Excel also, in a text file also. Okay, then all you have to do is you have to call this function read underscore CSV. Okay, it is very simple. So moving on ahead, then you had retrieving labels and columns. Already we covered this topic. You can write df.index to see all the row indices. Then you have df.columns to check out the names of the columns, and you can get an individual column by simply specifying the indexing parameter. Then you had modifying labels. Okay, if you want to change the labels, okay, just you can assign a value, a new list or an array. Okay, it can be a list, it can be an array. Okay, one dimensional. Then you can assign this value to df.index. Okay, same thing can be done using df.columns also. Then there was some attributes. Okay, so let's go through this one also on another data frame, which we'll create from scratch using a dictionary, let's say. Okay, so let's call our df again, data frame as df, which will override the previous one. Or let's say df1 is equal to, we have to create a data frame, so we'll use pd dot data frame, which is the constructor function for creating a data frame. Okay, so pd dot data frame, notice that there is a capital D and there is a capital F in the name of the function. Now we have to create the data frame from a dictionary, so we'll pass a dictionary. Dictionary will have multiple elements. Each element will represent one column. Okay, so let's say the name of our first column is name, and values are let's say Abhay, Rita, Clark, Jackson. Okay, so this is one element of the dictionary, comma. Let's say your second column name is, just arbitrarily, let me specify the column name as A, and the values are 1, 2, 3, 4. Similarly, let me add another column called B with values. Let's specify one value, okay, 8, which will be copied to all the rows. Okay, so this is very simple. df1 is the name of the data frame, pd dot data frame, which is the constructor. In the arguments, we are specifying one dictionary. Okay, so this is the one element of the dictionary in which their key is name and the values are Abhay, Rita, Clark, Jackson, a list. Okay, key is a string and values are a list. So this represents one column of the data frame, that there will be a column called name, and the values under that column will be Abhay, Rita, Clark, and Jackson. Okay, similarly, second column is A with these values, third column is B, just one value is specified, so that value will be replicated to all the rows. Okay, so let's execute this. Now if you check what is df1, we have created a data frame. Okay, any doubt in this? Anyone?
No, Ji.
Others?
No, Ji.
Okay,
No, Ji.
so moving on ahead, what we did was how to retrieve the index and the column. So df1 dot index. Okay, it was created by default, so that will be a range index. It says range index starting from 0, stop at 1, step is 1. Okay, now let's say you want to change the row index. Okay, df1 dot index is equal to, you want to specify a new one. 11, 12, 13, 14. Okay, so now if you print df1, the row index has changed 11, 12, 13, 14. Same way you can access the columns df1 dot columns. Okay, so the column names are name, A and B. If you want to change something, you can write df1 dot columns is equal to, here you can specify a list or an array also. Okay, let me specify, let's say we keep name as it is, comma, let's say we change A to score 1, or let's say marks 1 as m1, comma, m2 as marks 2. Okay, now if you print your df1, the column names have changed, right? The next was the attributes associated with the data frame, which are the data type, the dimensions, the shape, and the size of the data frame. So for this data frame, if I write df1.ndim, it means that how many dimensions are there, and then means the number of dimensions of the data frame. So this one has 2 dimensions. Similarly, df1 dot shape can be executed, which will tell you how many rows and how many columns are there. So first value represents the number of rows, second value represents the number of columns. Moving on ahead, you have df1 dot size, which will tell you how many actual data elements are there. So in 4 rows and 3 columns, you have a total of 12 values. Starting from above, ending at this 8, there are a total of 12 values. The last attribute is df1 dot dtypes, which will tell you the data types of the columns. Name is a string object, m1 is integer, m2 is also integer. Okay, any doubt up to this?
No G.
Okay, so moving on, we had the next topic as inserting rows to add a row. Okay, first we will work on rows. We'll see how to insert rows, how to delete rows. Then we will see how to insert columns and how to delete the columns. Okay, renaming already we have studied. Okay, in the previous example, already we had that how to rename. In this one we did, in this example, we renamed the columns, and in this example, we renamed the rows. Remember, this index refers to the row names, this 11, 12, 13, and 14. Okay, this is index, and these are called columns, df1 dot columns, name A, B. Okay, now this is the name of the row. This name is different. Okay, this thing is called the name of row. Okay, if you access a single row, its name will be shown as 11. Okay, name means it is an attribute that whenever you fetch a row or a column, that row or a column will be a pandas series, which will be associated with the name. Okay, so you can do that using df1 dot m1, which is the column marks. Okay, so here see name is m1, that name of this series is m1. Okay, then if you access, let's say we can do the same using lock and ilock also, df1 dot lock 11. Okay, at the index 11, so at the index 11 we have the first row of this data frame, 11, abhay, 1 and 8. So what it gives us is that name is abhay, marks 1 is 1, marks 2 is 8, and this name is 11. Okay, the same thing can be done using df1 dot ilock. Ilock will have positional argument, positional integer value, 0 for the first row, 1 for the second row, and so on. Okay, result will be same. Okay, now this index is 0, positional index is 0, but still name of this row is 11. Okay, now moving on ahead, inserting rows. To insert a row, first you have to create a series. Okay, because every row and every column of a data frame is a series object. So to insert a new row, let's again print out our data frame first. In this one, we want to insert a new row, adding a new row. So to insert a new row, first what we will do is we will create a series object which will act as a row. Okay, so to create a series, let's say we name it new row. Nr stands for new row. Okay, nr is equal to pd dot series, and you have to fill the data. Okay, first argument is data, which is a positional argument. You have to specify it at first position. Okay, others are index of and then name also. Okay, so first we will fill the data. You can write data is equal to, then you can specify the list, or you can directly specify the list. Okay, let's say the fourth one is Emerson is the first value, comma, value of marks 1 is, let's say, 6, comma, marks 2 is 8. Okay, we have specified the data part. We want here another row with values Emerson, 6 and 8. So we have specified that. Then whenever we create a series, we have to specify index also, right? That what is this value, this is name, this is M1, this is M2. You can specify the list, but the list already exists as df1 dot columns. Okay, the column names, name, M1 and M2. That is what you want the index for this. This you want it to be name, this you want it to be M1, this you want it to be M2. So in index you can specify directly df1 dot column. Okay, comma, then the name that we previously talked about, this thing, name. Okay, so for this one, let's say we want name is equal to, after 14, let's say we want it to be 15. Okay. If you press enter, so now NR is a series which has name 15, name is Emerson, M1 is 6, M2 is 8. It is not yet inserted into our data frame. It is just there, a series. Okay, to insert it into data frame, what we will do is df1 is the name of our data frame. So df1 is equal to df1, the old data frame, dot append the new row. Okay, append the new row. Okay, now df1 is having an additional row 15, Emerson, 6 and 8. All right, any doubt up to this? How to insert a new row?
No G.
Nagadevi, Rahul,
No G.
Gauri.
No G.
Okay, moving on. So append function can be used to insert a row once you create a series. Okay, then you have deleting rows. To delete a row, you can use the drop function associated with the data frame. Again, we will have this example on the data frame that we have created. So let's say we want df1 dot drop. We want to drop the, let's say, row with label 15. Okay, so if you directly write, let's say, 15 here, what happens is from this data frame, the row number with 15 name is deleted. Okay, but it will not change your original data frame. Original df1 is same. Okay, so to make the change in original, either you can use in place argument that will not be in your syllabus, so you can directly assign the new value to the old data frame. Simple, right? df1 is equal to df1 dot drop. What do you want to drop? You want to drop the row with name 15. So now the original df1 so the original df1 is dropped. The row is dropped from the original df1. Okay, so the next thing that we did was to insert columns. Okay, any doubt in deleting the row? Anyone?
No G. No G.
It is very simple. You just have to write this. Okay, in some examples, you'll see that here it is written as labels is equal to something like that. Okay, this will also have the same effect. Okay, and one more thing, if you have to delete multiple rows, let's say you want to delete df1 dot drop, I want to delete 13 and 14 both. Okay, so if you write 13 comma 14, what will happen is it will give you a value error because this drop function takes only one parameter. So if you have to delete multiple, you can specify those multiple labels as a list. Now it will work. Okay, you can drop multiple rows, but if you specify two values, there will be an error. If you want to drop multiple rows, just put all the row numbers in a list and specify, pass that list into the drop function. Okay, then it will be good to go. Okay, so We have not made the change in our original data frame, so that is still having 4 rows. Moving ahead, then the next topic was inserting columns. You have to add a new column to your data frame. Okay, so again, let's implement that on our data frame. This works the same way as in a dictionary. Okay, let's say we write df1. In brackets we write, let's say, m1 is equal to, here you write 5 comma 6 comma 7 comma 8. Now what happens is your df1 already had m1 as a column. Okay, already had m1 as a column. So what happens is that the values of that column are changed as 5, 6, 7, 8. The same way this will work in a dictionary. In dictionary also it is same thing. If the key is already existing, then the value passed will be changed in the dictionary. Okay, but if the key is not existing, it will add that as a new key. So same thing here. If the column is not already existing, if you specify something which is not already there, m3 is equal to 1 comma 2 comma 3 comma 4, then this sorry, this is df1. The name of our data frame is df1. So it will add a new column m3. Any doubt in this, adding a new column?
No, Ji.
Okay, you can also put a scalar value also. That scalar value will be replicated that many times. If you write df1 dot df1 and add a new column m4 is equal to, let's say, 0, then that value 0 will be replicated in all the rows. Okay, m1, m2, m3, m4. Okay. So the next thing is, if you want to insert a column at a specific location, you want to insert, till now we inserted all the columns at the end. Now you want to insert at a specific location, then we can make use of the insert function. Okay, now insert function takes some arguments. The first one is lock. Lock means at what location you want to insert your column. Okay, here the lock for this name is 0, location for city is 1, this is 2, this is 3, this is 4, like that. Okay, so where you want to insert, that you have to specify in lock. Then column is equal to, you have to specify the name of the column. Okay, then value is equal to, here you can specify either a list or an array of the values that you want to insert. Okay, so at that position your column will be inserted. Again, let's try that out in our data frame. Let's call it in df1 itself we have to insert. So df1 dot insert is the name of the function. In the parameters, the first parameter is log, at which location. Let's say we want to insert it after name. After name means this is 0, this is 1, we want to insert at 1. Okay, log is equal to 1 comma, then let's say you have to call the column as age. Okay, so we write column is equal to age comma, then values. At last you have to specify the value. Actually it is the name will be value. Okay, not values. So value of that column is, here you can specify a list or an array also. So let's say the value is 17 comma 16 comma 18 comma 17. Okay, pressing enter, again printing df1. Notice that the age column, the new column, is inserted at location 1. Okay, so this insert function can also be used to insert the columns at specific locations, also at the end also. Okay, works well. Any doubt inserting column at a specific location?
No, Ji.
Okay. So moving on ahead, then next is your deleting columns. Okay, so till now we have studied in the rows, we have studied how to rename a row, how to add a row, or how to delete a row. Then in columns we had how to insert a column and how to rename a column, that we already covered previously using the attribute df1 dot columns. Okay, so the next thing is deleting columns. Deleting columns can be done using 3 ways. One is with del statement, one is with pop, and one is with drop. Okay, data frames will act like behave similarly to dictionaries. In the dictionaries, how you can delete an object, how you can pop out a value. The same mechanism will work in here also. Okay, so moving on to our data frame df1. Let's say we want to delete the column m4. Okay, all you have to write is del statement df1. Then which column you want to delete? You want to delete m4. Okay, now if you go to your data frame 1, the m4 column is deleted. Okay, so simply del statement and the name of the column that you want to delete. df1 in brackets you write the name of the column. Okay, you can delete one column at a time for this mechanism. Okay, next using pop and drop functions also you can delete, drop or pop a column. Okay, first let's cover the drop function. Using drop, all you have to do is you have to mention the label. You can directly write age also, or you can write labels is equal to age also, and you have to mention axis is equal to 1. Okay, column axis is axis 1, row axis is axis 0. So you have to mention the axis is equal to 1. So let's try it out in here. If we write df1 dot drop, what we want to drop is m3 comma axis is equal to 1. So what it does, it drops this m3. Again, if you print df1, m3 is still there because this drop will not make the change in place. It will just return a new data frame. Okay, it returns a new data frame. Okay, the change will not be made in the original data frame. Okay, now let's say you write df1 dot drop m3. There will be a key error because m3 is not found in axis, because by default what drop function will do, it will drop the row. It will be dropping the row as we previously covered in the time of the rows. You write df dot drop 15. Okay, so df dot drop 15 means whatever the value is in here will be looked for in the row names, and that row will be deleted. Okay, now if you try to write df dot drop m3, what Python will do is it will look for m3 in row numbers, row index 11, 12, 13, 14. So there is no m3. Okay, so it will give you an error that m3 was not found in the axis. That is why we specify that we do not want to look in the axis 0, we want to look in axis 1. That we are not trying to drop the row, we are trying to drop the column. So when you write x is equal to 1, now it will look for m3 in axis 1, name, age, m1, m2, and m3. Okay, then it will give you the correct result, the data frame after dropping m3. Okay, any doubt in drop, how to drop a column?
No, G.
Exactly similar to dropping a row, only this argument you have to specify. Okay, by default the value of x is 0. Okay, when you drop a row, it is same as writing this x is equal to 0. Okay, now we are dropping a column, so you write x is equal to 1. Simple. Okay, moving on, the third option is to use the pop function to drop a column. Okay, using pop function, let's try it out first on a dictionary. Okay, let's say we have a d is equal to a dictionary in which you have a1 comma b2 comma c3. Let's say this is your dictionary. Okay, so what is d is a dictionary. Now if you write d dot pop a, what it does, it returns the value of the key a. Okay, we want to pop the value of the key a. The value is 1, so that value is returned. And if you print d, that a is deleted. The first element is deleted. Okay, so the same mechanism, the same pop function can be applied to data frame also. What is our data frame? Our data frame is df1. Now in df1, if you write pop function that we want to pop out, let's say m3, we want to pop out m3. So now when we press enter, what it does, it returns m3. And pops it out. It is deleted from the database and returned back. Okay, notice the difference. In the drop function, the column will not be deleted in place, not from the data frame. A new data frame will be created in which that column will not be there. Okay, but in the pop function, the column will be deleted from your data frame, actual data frame, and the deleted value will be returned. Okay, deleted value is 1, 2, 3, 4. Name of the column which has been deleted is M3. And the change is in place. In place means your df1 now does not have any column named M3. It has been deleted, popped out. Okay, so pop can be used to return the value and then delete also. Okay, any doubt up to this? Any doubt?
No, G. No, G.
Okay, good. So next is some basic arithmetic operations. Will not go into much detail. Just simply as you do with NumPy arrays, the same way you can have arithmetic operations on your uh, columns also. Okay, so let's say here we write df1 m1 plus df1 m2. What it does is the row indexes are as it is, and the result is m1 plus m2. M1 is 5, m2 is 8, so that results in 13. Okay, the same way you add a series. Okay, 6 plus 8 is equal to 14, 7 plus 8 is equal to 15, 8 plus 8 is equal to 16. Okay, the same way. Okay, pretty much same. So you can use these arithmetic operators to actually go ahead and insert new rows. Okay, using this mechanism you can perform any arithmetic operations. Okay, if I write let's say df1 m1 divided by 2. Okay, so this is your m1, 5 divided by 2. Okay, that value will be returned 2.5, 3.0, 3.5, 4.0. Okay, any arithmetic operation can be performed as you will do on NumPy arrays, as you will perform them on a series the same way. Okay, so let's say our data frame is this. Let's say we want to uh, add a new column called total marks, which will be marks of 1 plus marks of 2. So simple, how to add a new column? df1, you write the name of the new column. Okay, let's say total. Okay, what will be the value? We want the value of it to be df1 marks 1 plus df1 marks 2. Okay, so now your df1 will have a new column total, and the value of the total column is retrieved from the sum of m1 and m2. Okay, the simple way to insert a new column is combined with the arithmetic operations on the data frame columns, and with the combination of both you can insert a new column which performs some operation on the existing columns. Okay, any doubt up to this?
No, G.
Okay, the same way this the previous example that we had, the data frame that we imported from the CSV file, the same way they are inserting a new column total, and they are multiplying the Python score by the weightage, that this is multiplied by 0.4, this is by 0.3, this is by 0.3, then that arithmetic expression's result is added as a new column total. Okay, so any questions up to this?
No, G.
Okay, so I think around 15 are present today. So what is next is that you'll have a quiz on this part, data frame 1. Okay, Pandas 1. The first chapter is the data science with Pandas 1. Under this, up to now, we have covered that what is Pandas, then what is series, then we have arithmetic operations on series. Okay, then how to access objects of a series, elements of a series. Then we moved on to data frames and whatever we covered under data frames. Okay, I think many of you have not yet signed up in the Google class. Okay, some are missing there. So again, today I'll share the Google Classroom code. What you have to do is you have to join that classroom. In that classroom, one quiz will be shared shortly. Okay, you have to click on the link. It will take you up to a Google form. There will be some multiple choice questions and some paragraph type questions. You'll have to implement the quiz. Based on that, you will be assessed. Okay, and the score will be displayed to you in that Google Classroom itself. Okay, so those who have not joined, ask your friends to join. Those who are joined can help them join. If anyone does not know how to join, you can ask me also. You can ask your friends also. I think some 4 or 5 students are missing there. Okay, so if anyone is not having access, then also notify me. Send a message in the WhatsApp that I'm not able to use Google Meet or Google Classroom, and this and that is the reason for that. Okay, so the quiz will be shared shortly. You can attempt the quiz anytime. Okay, it will not be in the class time duration. It will have a starting time, it will have a stop time, submission time, and in that time, anytime you can just, it will be around 10 or 15 minutes of your time. Just sit and take the quiz and submit, and you'll be assessed on the basis of that. Okay, any doubts?
No G.
Okay, so I think it's time of your class. Then try to take down your own notes. Okay, I will share these presentations and the Jupyter notebook sheets, but try to take your own notes also, and try to have a little practice of whatever you do. Okay, because without practice, the programming will not be that efficient. Okay, if you have to learn how to code, then you have to write code by yourself. If you do not write the code, doesn't matter how many times you look at this class, doesn't matter how many ppts you go through, you will not be able to actually learn. Okay, so if you are not having access to a computer, you can use Python on your mobile phones also. You can download Python, and if even if that is not possible, then you can use online Python interpreters also. Okay, because mostly you have to just write one line statements. If you have to execute a function or anything, it will be a one line statement. So it's better to download Python on your mobile phones. If not, then go online and just in Google search for online Python interpreters, so you can write commands online and get results also. Okay, so take care of your health. We'll see you in the next class. Goodbye.
Bye G.
Bye, thank you.
धन्यवाद
Bye, Ji.
धन्यवाद.
धन्यवाद